All right, so on the journal, new EQ because it's a new unit, and then who remembers the subatomic particles? Roberto, what you got? Remember neutron, but yeah. Electron, proton, and neutron, yes. And do you remember their charges? Neutral, perfect, that's perfect. Electron negative, proton positive, and neutron neutral. So on this unit, we're going to be talking about the atom and how those different things were discovered, the different subatomic particles were discovered, and the different theories, and then kind of some of the things that we'll see on the periodic table. So like I said, you have videos to watch. There was one for today, and then you have 2 more this week. These are my tutorial times. They're also posted in Google Classroom and sent them out on SportsU and on the board. Really, there's not a lot going on as far as requizzing or anything, but you can always come into tutorials if you have questions. But if you were absent for the test on Friday, measuring matter test, then Wednesday is your last day to make that up, Wednesday in the afternoon. And then these other 3 things I have quizzes as far as the last date. Those are quizzes that we're going to be taking. One on Tuesday, one on Thursday, and then one on Monday. I won't be here on Friday, so I went ahead and listed the one for Monday on that one. Did I have anybody in this class that I gave extra time for on the review? I had some people out sick, so I did that. All right. So let's look at our notes. All right, so if we start here on our notes, there's kind of 3 laws or 3 theories that govern chemical reactions. The first one is the law of conservation of mass. And it states that matter can neither be created nor destroyed during a chemical reaction. So that's why we have to balance chemical reactions. When we get to that point, which won't be too far away. Yes, ma'am. You can come sit right up here. It doesn't give me any in between. It makes me go to 200 and then it's too big. I can try to percent in this. I'll have to see if I can still do it with my iPad. All right. The next one is the law. Can you see, is that okay now if I do it like that? Okay. The law of definite proportions states that a chemical compound contains the same elements in exactly the same proportions by mass, regardless of the size of the sample or the source of that compound. So NaCl is table salt, sodium chloride. I can have a small container or I can have a large container. Still by mass, it's going to be 39.34% sodium and 60.66% chlorine. It's always going to combine with 1 sodium atom and 1 chlorine atom for that particular compound. And then the last law that kind of governs the things that we look at really throughout the year, law of multiple proportions, states that if 2 or more compounds are composed of the same elements, then the ratio of the masses of the second element combined with the certain mass of the first element is always a ratio of small numbers. I will never get you to write that, but what it's trying to say in a whole lot of words, if I have the elements carbon and oxygen, I can take 1 carbon and 2 oxygen atoms. That's going to give me carbon dioxide, which is in the atmosphere all the time. The plants use it, it's safe. I can take the same 2 elements and just take 1 atom of each and combine. And now I have carbon monoxide, which is dangerous and poisonous. So that's a really long law that's really trying to say that. All right, so we're going to talk now kind of about the atom today and how the different things were discovered within the atom. I keep on forgetting I have that. So John Dalton, he was an English school teacher, And he came up kind of with the first explanation of the atom itself. And it was called Dalton's atomic theory, and it had 5 postulates or 5 parts to it. And the first one was all matter is composed of extremely small particles called atoms. Atoms of the same element are exactly the same in size and mass and other properties, and atoms of a different element are different. Number 3, atoms cannot be subdivided, created, or destroyed. Number 4, atoms of different elements combine in simple whole number ratios to form chemical compounds, so you can't have a partial part of an atom. And number 5, in chemical reactions, atoms are combined, separated, or rearranged. And that goes back to the law of conservation of mass. So I'm going to put a little star by these. All of these were found to be true, except for some small differences in number 2 and number 3. So whenever he came up with this postulate or these postulates, it was quite a while ago before there were a lot of really good experimental processes. So the fact that they have stayed true and have been found to be true was pretty impressive. So like I said, 2 and 3 have changed a little bit too. So you're gonna have to find some place to write this within your notes if you just want to go back up to 2 and 3 and kind of notate. Number 2 said that all of the same elements are exactly the same, and in fact that's not true. There's isotopes of elements, and they have a different number of neutrons, and therefore they would have a different mass. And then number 3 said atoms cannot be subdivided, created, or destroyed. But now we know that there are subatomic particles, protons, neutrons, and electrons that they can be divided into. All right, the next thing we're going to talk about is kind of some of the early models or some of the different models of the atom, and then you'll finish that out on your timeline, which I'll give you whenever we finish up our little bit of notes. All right, so talking about the atom and how it's arranged, kind of the first person to talk about the atom was Democritus back in 400 BC. And he came up with the word where we get atoms from, atomos. And he said that all matter was composed of tiny particles. And obviously he didn't have any really kind of experimentation. He just did this by the observations that he made. His teacher and mentor was Aristotle, and he disagreed with his student. And of course, people believed Aristotle instead. So it took about 2,000 years until people realized Democritus really was right with what he said. So J.J. Thomas discovered the electron using the cathode ray tube experiment. So that was the first subatomic particle that was discovered. And the reason it was discovered was because it was charged negative charge, and small. So it was the easiest of the subatomic particles to manipulate. Since it was negative, you could put it like through a magnetic field and make it go one way or another. And then since it was small, once again, that would lead to being able to be manipulated during experiments. And from that, they came up with the plum pudding model, which helped to predict protons eventually, because scientists knew that atoms were overall neutral. So if there was something negative in the electron, there also had to be something positive in the proton. The plum pudding model also proposed that since electrons have a much smaller mass than the atoms, there must be another particle that was going to account for the atom's mass. So plum pudding is an English food. I don't know if it's a dessert, but it's like, if you can think of it like a bowl of oatmeal that you've added some raisins to. So they said that all the oatmeal was all positive. So it was like a positive area. And then if you added the raisins would be your electrons. So that was kind of the first model that was derived. Rutherford then came along and he used something called the gold foil experiment to discover the nucleus, or the fact that all the positive was concentrated in one area and not spread out. So he took alpha particles and he shot it through this foil of gold. He expected all of them to go straight through, but some were reflected or refracted. I don't know if that's the right word, but some came back to him and then some kind of just went off in various directions. So from that, he said, well, that can't all be positive. They must just be hitting positive things here and there that are very solid. So from that, he was able to develop the fact that there was a positive nucleus, and that became the nuclear model. He said the nucleus is a small, dense, positive region. And that's where most of the mass of the atom comes from. It doesn't take up very much space. It's very small, but it still has the mass of the atom. And well, let me go back one. I'm sorry, y'all. And at the top of y'all's now, I don't think I can go back. I probably can. I probably just don't know how to. So at the top of y'all's, you'll have some room up here. Rutherford just made his discovery in 1911. So by that point, the proton and the electron had been discovered. So that explained why atoms are neutral. And then in 1932, another scientist, Chadwick, came along and he discovered the neutron, because that's what we had left. And that was due to a mass difference. So in other words, the positive and the negative, proton, electron, that accounted for the atom being neutral. But if you added them up, there was still some mass of the atom that was missing. So that made them know that there was another particle and it had to be neutral. And so eventually, about 20 years later, that's how the neutron was discovered. All right, are we good? All right, so now we'll just talk a little bit about the three particles as we move through the atom. Atom is the smallest particle of an element that retains the chemical properties of that element. And we know that there's two regions, the nucleus, which has the protons and the neutrons. And that's where we get our mass of the atom from. And then the electron cloud, that's going to have the electrons. And that's where the volume of the atom comes from, because the electrons can spread out. So that gives you the volume, and then the mass is concentrated within the nucleus. Yes, ma'am. Perfect. Exactly. All right, are we good? All right, so we'll start off with the proton. positively charged, located in the nucleus. The number of protons does not vary. That's very important. Under ordinary chemical reactions. So if we did a nuclear reaction, yes, that would change, but we're talking about normal chemical reactions. So this is what you ID or identify an element with. So in other words, if I say, look at element number 6, I'm talking about the atomic number. So that would be carbon. You don't identify an element by how many electrons it has or how many neutrons, because those can change. And its mass is 1 AMU, which is extremely small. You can see from that number to the -24, but still it is much larger than an electron, about 2,000 times larger than an electron, even though itself is very small. Good. All right, then we have the neutron, high energy, neutrally charged and located in the nucleus. The number of neutrons can change for an element, and we call those isotopes. Talk about those tomorrow. Neutrons stabilize the nucleus by nuclear forces. So nuclear forces are what holds the protons and the neutrons together in the nucleus, because you don't have a positive and a negative charge to hold them together. And like I said, that little 0 means it's neutral, and it has the same mass as a proton. All right, and then our last little guy is our electron, negatively charged, located in the electron cloud. It also can change for an element, and it does that when ions are formed, which we'll start talking about tomorrow. Y'all may have probably had a little bit of that in junior high. Electrons are responsible for the chemical reactivity of an element, what kind of bonds they are going to form, especially a certain type of electrons that are the farthest out or in the highest energy level. Does anybody remember what those are called? Starts with the B. Nobody? The electrons that are out the farthest energy level. So they're the ones that form bonds. With what nobody remembers on all the classes. Starts with a V. Valence electrons. Yeah, your valence electrons. Those really are the part that has to do with how reactive something is. And then you can see that it has a tiny mass if you compare it to the other two particles. All right, and oops, jump back there. All right, so the nucleus, I kind of feel like we've said this, but we'll say it one more time, contains the mass of the atom, and then the electron cloud is going to contain the volume. And we're going to stop there on our notes, and I'm going to give y'all some time to work on your timeline. All right, so like I said, this is the one that you're going to be putting your answers on. And then this is a paper that has all the information. So you'll read your little paragraph or so about each scientist, and you'll come up with probably 3 or 4 points that you think are important. And like I said, you're looking for things like what their discovery was. If they did do an experiment, then what they used for the experiment. So like gold foil experiment, if they came up with a subatomic particle, or so the kind of big pictures are what you're looking for. And then on your paper, there's an example of the one already done for Democritus. So you can kind of look at that and compare to the paragraph, and that kind of gives you an idea of what to do. Huh? Oh yeah, on that one paper, yes, ma'am. And so you can see it has their name and then the dates, and it goes through the different summaries, and like I said, also the subatomic particles. Anybody have any questions on that? Straightforward. No, you don't. Not all that. You do not have to use complete sentence on that. You kind of just do your little points.